Hey math fans, test 3 lesson 4. If your swords are ready, let's get started. Today we'll be converting mixed numbers and improper fractions. We'll be continuing patterns with blocks, and we will be expressing probability as a fraction. So to start off, we're going to convert some mixed numbers and improper fractions. So for mixed fractions, we're going back to our friend mathisfun.com. And a mixed fraction is a whole number and a proper fraction combined. So, for example, you could see here 1 3/4. You have 1 whole pizza, you have 3/4 of another pizza. Examples would be 2 3/8, 7 1/4, 1 14/15, 21 4/5. You'll notice that each one is made up of a whole number and a proper fraction together, and that's why it's called a mixed fraction or a mixed number. So when we name fractions, we give a name to each part. So here we have the whole number is 2. The numerator, of course, goes on top of the fraction and it's 1, and the denominator is 3. A big thing to remember, I know sometimes in your younger grades they tell you that the bottom number is how many pieces there are altogether. That's not right. It's actually how many pieces are in one whole thing. So for example, if this is talking about chocolate bars, you would have 2 whole chocolate bars and 1 piece of another chocolate bar, and the 3 tells you that each chocolate bar was chopped into 3 pieces. So there's 3 types of fractions, and you can see them down here. A proper fraction has a smaller numerator than denominator, so 3 out of 5. An improper fraction, the numerator is bigger than the denominator, so 9/5. And a mixed fraction is when you have a whole number mixed with a proper fraction, so 2 1/3. Now, mixed numbers and improper fractions both show the same thing. So here we have 2 ways of writing the same thing. We have 1 whole pizza, and then the pizza's been cut into 4, and we have 3 pieces of the extra. So that gives me 1 3/4. Over here you can say it's the exact same amount of pizza, but I've cut both of the pizzas into 4s, and I've written it as an improper fraction, so I've counted how many pieces. 1, 2, 3, 4, 5, 6, 7. 7/4. So there's other ways to do this, but for now, when you're converting between these two, if you want to say how you would write this as an improper fraction, the best thing to do is draw it out. Draw 1, and then draw 3/4, cut it all into 4, and count up how many pieces you have. The same thing would happen if I asked you to convert an improper fraction into a mixed number. You would draw out your 7 pieces, knowing that because there's a 4 on the bottom, you had to cut each pizza into 4. And then you could write you had 1 whole pizza and 3/4 of another pizza. There's other ways to do this, but for now, that's what we're going to worry about. Yeah, we'll just leave it at that for today. So that's all there is to converting mixed fractions and improper fractions. If you really want to go on, you can go to Math is Fun and read this little part. So we're going to move on and take a look at continuing patterns with blocks. So here we have Madeline built a staircase with linking cubes, and we want to write a pattern for Madeline's staircase, and we want to predict the number of cubes in step 10, explain our prediction, and then check it. So the first thing we're going to do is start by checking a pattern, which I did by making a chart. So in step 1, she has 4 blocks. In step 2, she has 6 blocks. In step 3, she has 8 blocks. So the pattern is going up by 2. Pretty basic. Now I could keep counting by 2s, but that's going to take me a while. And it's not a big deal when they're asking me about step 10, but what if they asked me about step 100? So the easier way is to find an equation for the table. Now, what that means is, what are we doing to this number to turn it into this number? So 1 times 4 is 4, so let's see if that works here. 2 times 4 is 6. Nope, that doesn't work. There's a little trick that works really, really well for this. When you have a table like this, if you can't find the solution right away, chances are that you're doing times something plus something. And last year I learned a really cool trick for figuring out what that is. So what you do is you look at the difference between 2 numbers. It can be any 2 numbers. In this case, 1 and 2, the difference is 1. 4 and 6, the difference is 2. What times 1 equals 2? It's times 2. That means that these are all going to be times 2. 1 times 2 is 2, plus 2 is 4. 2 times 2 is 4, plus 2 is 6. 3 times 2 is 6, plus 2 is 8. So the pattern rule for this table is that you take the steps, you go times 2 plus 2, and it tells you how many blocks to use. That would work if I did it on another area too, like if I went 1 and 3, the difference is 2, and then 4 and 8, the difference is 4. 2 times 2 is 4. It would still give me times 2. That's the quick way to find equations for tables. So now that I know that it's step times 2 plus 2 equals blocks, I know that 10 times 2 plus 2 is 22. She will use 22 blocks in the 10th step. Would I have gotten that same answer if I kept counting up by 2s? You bet I would have. But this was a lot faster, and in later questions they're going to start asking you bigger numbers. You would not want to have to count by 2s all the way up to the 100th step. And finally, we're going to do a study jam about expressing probability as a fraction. So without Flash on the iPad, I had to get a little creative, so we're just going to walk through it together, like this.
Sam and I were hanging out before school. Sam said that if I pulled a jack out of the deck of cards on my first try, he would buy me lunch. But if I didn't pull out a jack, I would have to buy him lunch. Before I jump into this deal, I want to calculate the probability. First, find the number of favorable outcomes. I know that each deck of cards has 4 jacks. That means I have 4 favorable outcomes, or 4 chances. Next, we need to figure out the number of possible outcomes. There are 52 cards in a deck, and I have an equal chance of picking any one of them. So that means there are 52 possible outcomes. Probability can be expressed as a fraction. Place the number of favorable outcomes over the total possible outcomes. So our fraction is 4 favorable outcomes, me picking out a jack, over 52 total possible outcomes, all the cards in the deck. The probability of me picking a jack is 4 out of 52. We can reduce that to 1 out of 13. Those odds don't sound too good to me, so I think I'll pass. When probability is shown as a fraction, it represents some number between 0 and 1. We can use a number line to compare different probabilities to see whether something is more or less likely to happen. 1/2 is in the middle of the number line. 1/2 means that something is equally likely to happen. Let's use the number line to compare my chances of picking a jack with Sam's chances that I won't pick a jack. Place the first fraction on the number line. In my case, 1 out of 13 is way less than 1/2. Next, place the second fraction on the number line. Since there are 48 cards that are not jacks, Sam's chance of me not pulling a jack out of the deck was 48 out of 52, or 12 out of 13. Now we can compare the two probabilities. It's clear that Sam's chances are way better than mine. Sam's probability is really close to certain, while mine is much closer to impossible. Since 1 out of 13 is so close to 0, I know that the probability of pulling out a jack is not very likely. On the other hand, 12 out of 13 is pretty close to 1, or certain. Sam's got a more than likely chance that he'd win. Good thing I didn't take that deal.
And we're done for today. You just have to do this review and get it handed in to me tomorrow. So number 1, write these probabilities in fractions. A, getting a heads when you toss a coin, and B, drawing a king from a deck of cards. B, write 3 examples of mixed numbers. And C, if you continue Madeline's pattern, how many blocks will she use in the 50th step? And I put the picture there to help you again. Have a great night. Bring these answers tomorrow, and I'll see you then.